So in this video, we're going to be talking about brain scans, and we already know that brains are incredibly complex. So by scanning them, we're able to gain a lot of useful information to try to understand them on a better level. So if we go back to thinking about Phineas Gage, he unfortunately suffered a brain injury. So there's loads of information about Phineas Gage that we can access to learn more about what happened to him. But in 1848, when he was 25 years old, he had an iron rod go in through his face and damage his frontal lobes. So the reason why the case study of Phineas Gage is so important is because he was able to continue living after a huge chunk of his brain was damaged. He wasn't the same afterwards. He did end up having personality changes. So we were able to see that certain areas of the brain are responsible for different functioning. So although a huge chunk got damaged, he was still able to live and be healthy, but his personality had changed. So this informs us that different areas of the brain do different jobs. So when we studied the biological approach in the first year of our A-level studies, we looked at this in quite a lot of depth. So we've got different regions of the brain, which all are responsible for different jobs. So Phineas Gage, when he ended up having his brain injury, it was actually located in the frontal lobe here. So it would have been at the front of his brain. So we know that this area is likely to be responsible for certain jobs that the other areas are not responsible for. And then within those regions, we have other sections of the brain. So although all of these are quite blurry and hard to make out, you can go on that 3D brain app and look at them in more depth. So we know that we've got different regions of the brain, and then within the regions there are other sections of the brain which are all really important, and they all have different jobs. Also within the brain, we have the central nervous system. So this is connected to our spinal cord and is responsible for really important jobs. So it's how the rest of our body and our brain are interacting with each other. So you can see here that there are different activities related to these sections of the brain. So the human cerebral cortex is a highly folded region, and although it's only 5 millimeters thick, its total area is around 0.5 meters squared. And this map of the cerebral cortex shows the regions responsible for different functions. So Walter Penfold was actually responsible for mapping different areas of the brain. Penfield was a pioneering brain surgeon, and he was responsible for mapping the motor cortex using mild electrical currents. I've linked some information about Penfold and all the other things I think are relevant within this video in the description box. He started looking closely at the brains in 1940. While operating on epileptic patients, Penfield applied electrical currents to the surface of the patient's brain in order to find problem areas. So since the patients were actually awake during their operations, they could tell that Penfield what they were experiencing. So probing some areas triggered whole memory sequences. For one patient, Penfield triggered a family song that sounded so clear that the patient thought that it was actually being played in the operating room. During these operations, Penfield watched for any movement of the patient's body, and from this information he was able to map the motor cortex. Today's measures of looking at the brain, we do not have to open up people's heads and look at their brains while they are still awake. We're able to scan their brains in a range of different ways. So MRI is a popular brain scanning tool that we use, and this is when the patient's heads are not open, so much nicer for the person involved. There are also CT scans or CAT scans. Here are some examples of the results of some. And here's an example of someone experiencing it. So you can see that the person goes in a big dome, and then their brain will be scanned and show pictures like this. So this type of scan produces a two-dimensional image or a slice of a section of the body. So it doesn't have to just be a brain scan, you can also scan other regions of the body. So MRI scans, shown here, are where magnetic fields and radio waves are used in combination to look at the brain in more depth. Similarly to CAT scans, the MRI scanner is a large tube that contains these powerful magnets that are part of the process of scanning the brain. So you lie inside the tube during the scan, very similar to the image on the last slide. So next we've got PET scans, shown here again, and these show you images of the brain that help you reveal how tissue and organs are functioning. So this actually shows you, so these can be useful for detecting disease and other abnormalities. So because PET scans and CT scans will only show certain activities, they're often used together or with an MRI scan. So all of these different types of brain scans can be incredibly useful. Please look at the information in the description box, which will lead you to more information which will help you understand brain scans better.